When you see a question with wild radicals or exponents, the first thing that should come to mind for you is use the exponent rules and sometimes the radical rules, but mostly the exponent rules to simplify and rearrange what you have to see what it matches in the choices. So here we have 1 over the square root of x all to the n power. And let's begin with this radical, the square root of x. This is one of our exponent rules. When you have the square root or any sort of root of some term, you could turn that into a fractional exponent. So just as an aside, the square root of x, I'm going to put that 2 as the index. We technically don't have to do that. If there's no number here, we assume it's square root. But I'm going to put the 2 there just for our next step. And also, there technically is a 1 here, right? It's x to the first power. You can write it that way. Again, we don't normally write that because it's sort of unnecessary. But this allows us to know, okay, how do I turn this into a fractional exponent? So essentially what's going to happen is this index of the radical, we're just going to swoop that underneath the 1, underneath the exponent, under the radical bar as the denominator of the fraction. So this is going to be the same as x to the 1/2. So let's rewrite our expression here. So it's 1 over x to the half to the n. Now, here is another exponent rule we can apply. When I've got this exponent in the bottom, it may call to mind the negative exponent rule. So when you have x to the negative a, that it can be rewritten as 1 over x to the a. So we put this in the denominator, and we also change the sign of the exponent, in this case from negative to positive. We have this here. It's just in the other direction, right? We have this in the denominator. So let's turn that into a negative exponent following the rule. So it'll be x to the negative 1/2 all to the n power. Okay, so far so good. Now we can apply a third exponent rule, which is when you have a power or a exponent, a base and an exponent raised to another power, you can combine these by multiplying the exponents. So if I have x to the a to the b, I can just write that as x to the a times b. And so here, this is exactly what I have. I have x to the negative 1/2 to the n. And so I can just rewrite this by multiplying negative 1/2 times n. And when I do that, I'm going to get negative n over 2. And if we look at our choices, that looks like it matches choice B.